Something is alive 800 meters beneath Antarctica's ice. Scientists drilled down and found amphipods swimming in total darkness. Small creatures in water that hasn't seen sunlight in thousands of years. No food source. Temperatures below freezing. They've been sealed under the ice longer than human civilization has existed. They shouldn't be alive, but they are. And beneath them lies something the world's most powerful nations are racing to control. China is building permanent bases across Antarctica. Russia is running geological surveys. The United States is falling behind. What's hidden under 5 kilometers of ice that's worth this fight? Antarctica is the 5th largest continent on Earth, larger than the United States and Mexico combined. It holds 70% of the planet's fresh water locked inside an ice sheet, thick enough to bury mountain ranges. Temperatures drop to -90 degrees Celsius. Winds exceed 200 miles per hour. In winter, parts of the continent don't see the sun for months. From above, it looks like empty wasteland. But Antarctica is a library, and every layer of ice is a page recording Earth's atmospheric history. Snow falls year after year and compacts under its own weight. Each layer represents a year, like tree rings. As the snow compresses, air gets trapped between the grains. Tiny bubbles of atmosphere sealed in time. Scientists drill down and pull up long cylinders of frozen history called ice cores. The deeper the core, the further back in time. One of the oldest continuous ice cores ever recovered was drilled from nearly 3 kilometers down. It contains air that's 1.2 million years old. If it warms, that record disappears forever. Trapped inside these bubbles are carbon dioxide levels, methane, volcanic ash, and temperature signals from before modern humans existed. The ice records when the Sahara was green and when mammoths walked across continents. It shows carbon dioxide levels that were half of what they are today. The ice doesn't forget. But this atmospheric archive is only what sits on the surface. The real story lives underneath. In some places across Antarctica, powerful winds strip away fresh snow and expose something unexpected. Fields of blue ice stretching for kilometers. This ice began as ordinary snowfall compressed until air bubbles were forced out. With no fresh snow on top, light penetrates deeper and the ice absorbs red and yellow wavelengths, leaving it glowing blue. Some of these blue ice fields reveal ice that's hundreds of thousands of years old, exposed directly to the surface. But beneath even the oldest surface ice, water is moving. Beneath Antarctica, thousands of rivers and lakes form a connected drainage system, invisible from above. Some of these subglacial lakes hold volumes of water comparable to major reservoirs. When they drain, billions of liters of water release over just a few days, traveling hundreds of kilometers across the continent under the ice. As water redistributes below, the ice above responds. The surface lifts and settles by meters as pressure shifts underneath. We've barely touched this hidden world directly. If you add up every place humans have physically reached beneath the ice, it covers roughly the size of a basketball court. So instead, scientists fly helicopters low over the surface, carrying massive electromagnetic sensors. These systems send signals down through ice and rock, revealing what's frozen, what's liquid, and what's moving below. We're mapping a hidden continent by echolocation. And occasionally, this hidden system reaches the surface. A deep red stain spills from Taylor Glacier, streaking the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, no one could explain it. The water comes out clear but oxidizes on contact with air, turning deep red from dissolved iron. This is ancient briny water, more than twice as salty as the ocean, which keeps it liquid even at -5 degrees Celsius. It's been sealed beneath roughly 400 meters of ice for millions of years. The water has been moving through this subglacial system longer than modern civilization has existed. What makes blood falls particularly strange is what scientists found living in that water. Microbes that have been cut off from sunlight and atmospheric oxygen for potentially 2 million years. These organisms survive by metabolizing iron and sulfur compounds in the water. They're essentially breathing rust. The water itself is a time capsule. Chemical analysis shows it originated from an ancient ocean that got trapped beneath the ice as Antarctica froze over. That means there's a piece of Earth's prehistoric ocean still flowing beneath the glacier, preserved in near-perfect isolation. Bloodfalls gives us a glimpse into what these hidden rivers transport beneath Antarctica. Iron, organic carbon, sulfates, and nutrients that should have been locked away forever, but instead keep flowing through invisible channels in the rock and ice. There are thousands of subglacial outflows like this across the continent. Most never reach the surface. When that nutrient-rich meltwater enters the ocean, it fuels phytoplankton, which support krill and everything above them in the food chain. The system begins beneath the ice and ends with the largest animals in the ocean. But Bloodfalls reveals something else. If water this old can stay liquid and flow beneath the ice, if organisms can survive in it for millions of years without sunlight, what else is moving down there that we haven't found yet? Go down more than 3 kilometers and you reach one of the largest lakes on Earth. Lake Vostok is 240 kilometers long and 50 kilometers wide, completely sealed beneath the ice for millions of years. It has never seen sunlight. It's been isolated from Earth's atmosphere longer than humans have existed. Lake Vostok isn't unique. There are nearly 700 subglacial lakes scattered across Antarctica. In the few scientists have sampled, they've already found evidence of life. In Lake Willans, microbes survive by extracting chemical energy from rock. In Lake Mercer, researchers found microbial signatures preserved in the sediments. These organisms exist in conditions we used to think were incompatible with life. Complete darkness, extreme pressure, isolation for millennia, no connection to the surface biosphere. They're surviving on chemistry alone. This makes Antarctica one of the closest natural analogues we have to icy moons like Europa and Enceladus, moons with oceans sealed beneath frozen shells. If life can exist under kilometers of ice on Earth, it changes what we consider possible elsewhere in the solar system. Antarctica isn't hiding aliens, but it's showing us what alien life might look like. And the deeper you go, the more heat you find. Beneath West Antarctica are dozens of volcanoes hidden under kilometers of ice. Some of them are active. They don't erupt upward the way surface volcanoes do. The weight of the ice suppresses explosive blasts. Instead, heat builds below, melting ice from underneath and carving chambers of water and steam. Scientists have found ash layers trapped in ice cores, evidence of eruptions that happened while the ice was forming. More recent seismic data suggests some of these volcanoes are active today. One of them, Mount Erebus, is the southernmost active volcano on Earth, sitting partially exposed on Ross Island. But most remain completely hidden. This geothermal heat wasn't fully accounted for in early ice models, which helps explain why parts of West Antarctica are changing faster than expected. The Thwaites Glacier, one of the fastest melting glaciers in Antarctica, sits directly above a geothermal heat source. The ice above is thinning not just from atmospheric warming, but from heat rising through the bedrock below. When ice melts from underneath, it creates a layer of liquid water between the glacier and the bedrock. That water acts as a lubricant, allowing the glacier to slide toward the ocean faster than it would on bare rock. This accelerates ice loss in ways that climate models based only on surface temperatures can't fully predict. The ice isn't only responding to warming from above, it's being heated from below. And these volcanoes sit on the surface of something much larger, a continent buried beneath everything you've just descended through. Using data from millions of measurements, scientists can digitally strip away the ice. What's left is a vast, rugged landscape. Mountain ranges comparable to the European Alps lie completely buried beneath the ice. The Gamburtsev Mountains stretch across the interior, their peaks rising thousands of meters, unseen for millions of years. Denman Canyon cuts through the bedrock nearby, the deepest land canyon on Earth, plunging more than 3.5 kilometers below sea level. Ancient river valleys run between them, preserved exactly as they were tens of millions of years ago when Antarctica was green and forested. This bedrock reveals something fundamental. Antarctica isn't one continent underneath, it's two very different geological worlds. East Antarctica is ancient, thick and stable, part of one of the oldest pieces of continental crust on Earth. West Antarctica formed differently. Tectonic forces stretched the crust apart over tens of millions of years. It thinned, fractured, and sank, creating deep basins long before ice ever arrived. That thinning brought heat closer to the surface, which explains why West Antarctica hosts dozens of volcanoes beneath the ice. Strip away the ice today, and much of West Antarctica sits below sea level. The continent breaks apart into islands and highlands. Fossilized pollen and root systems preserved in the rock show this was once a forested land with rivers and temperate climates. And then there's the Wilkes Land gravity anomaly, a circular structure 300 kilometers wide buried beneath East Antarctica. Its origin is still debated. It may be one of the largest impact scars on Earth. For millions of years, the weight of the ice has pressed Antarctica downward, pushing the crust into the mantle below. When ice is removed, the land doesn't just sit there. Over centuries, it slowly rises back up, changing coastlines and reshaping stress deep within the crust. This bedrock remembers a world without ice, and this is what nations are positioning themselves to control. Antarctica shares the same deep geology as South America, Africa, India, and Australia. Continents rich in coal, oil, metals, and rare elements. Geological surveys suggest vast resources buried beneath the ice, potentially worth trillions. Coal beds have been found in the Transantarctic Mountains, exposed where glaciers have retreated. Iron ore deposits exist in multiple regions. Surveys have detected potential reserves of copper, gold, platinum, and chromium locked in bedrock that hasn't been accessible for millions of years. Then there are the rare earth elements. These are materials critical for modern technology that most people have never heard of. Neodymium for electric motors and wind turbines, lithium for batteries, cobalt for electronics. China currently dominates the global supply of these elements, and competition for alternative sources is intensifying. Petroleum geologists believe Antarctica's continental shelves could hold substantial oil and gas reserves, particularly in the Ross Sea and Weddell Sea regions. Russia's surveys have focused heavily on these offshore areas. The estimates vary widely, but some projections suggest reserves comparable to major oil-producing regions elsewhere in the world. For now, all of it is protected by the Antarctic Treaty signed in 1959, which designates Antarctica as a zone for peace and science, prohibits military use, and suspends territorial claims. Mining and resource extraction are banned, but that protection has limits. The treaty can be reviewed, and when it is, the rules could change. Some countries are already moving. Russia has carried out extensive seismic surveys and mapped potential oil and gas resources in Antarctic waters. China is rapidly expanding its Antarctic program, building new year-round stations and investing heavily in logistics, mapping, and polar research. Meanwhile, the United States Antarctic program is facing aging infrastructure and funding uncertainty. The balance is shifting. The subglacial lakes, the hidden biosphere, the ancient rivers, the ecosystem powered by nutrients flowing into the Southern Ocean, all of it exists in a fragile balance that took millions of years to create. Antarctica holds 70% of Earth's fresh water. That alone makes it valuable beyond measure. In a world facing water scarcity, control over the largest freshwater reserve on the planet becomes strategic power. The buried continent also holds rare earth elements critical for modern technology. Metals used in batteries, electronics, and renewable energy systems. Resources that are running short in more accessible parts of the world. And then there's the position itself. Antarctica sits at the bottom of the world, with influence over Southern Ocean shipping routes, fishing grounds, and climate systems that affect the entire planet. Presence there means influence over decisions that will shape how we respond to environmental changes in the coming decades. Countries establishing infrastructure now, building bases and supply lines and mapping resources, are positioning for a future where Antarctic resources become accessible. Whether through technological advances or changes to the treaty framework, they're preparing for possibilities that don't exist yet, but might soon. The amphipods found swimming 800 meters beneath the ice are part of an ecosystem we don't fully understand. The subglacial lakes hold microbial life that's been evolving in isolation for millions of years. The rivers transport nutrients that feed the entire Southern Ocean food web. Change one part of this system, and the effects cascade through everything else. Heat from below shapes how ice moves. Ice controls where water flows. Water carries nutrients. Nutrients sustain life from microscopic organisms to the largest whales on Earth. Systems like this take millions of years to form. They can be disrupted far faster than they can recover. For over 60 years, the Antarctic Treaty has held. Nations have cooperated on scientific research while keeping military and commercial interests at bay. But cooperation requires trust, and trust requires that all parties believe the rules will continue to apply equally. As technology makes once unreachable places viable targets for extraction, and as resource scarcity increases pressure to find new supplies, the incentive to maintain protection weakens. Some environments function precisely because they've been left alone. Antarctica is one of them. The life existing in its subglacial lakes, the atmospheric records preserved in its ice, the ecosystems supported by nutrients flowing from beneath its glaciers. All of this depends on the continent remaining largely undisturbed. The countries building infrastructure across Antarctica right now aren't there just for science. They're establishing claims, positioning, preparing for a future where the protections that currently exist might not. What's beneath Antarctica isn't just ice and rock. It's a record of Earth's climate history. It's ecosystems that exist nowhere else. It's freshwater reserves the planet depends on, and it's resources that nations believe are worth fighting over. The race is already underway. The question isn't whether Antarctica will face pressure to open for extraction. The question is whether the protections designed to prevent that will hold when tested. What do you think should happen to Antarctica? Let me know in the comments. If you want to see more videos like this, hit the like button and subscribe. Thanks for watching.